Okay, in section 3.1, we looked at the basic graphs of sine and cosine and tangent and cotangent and cosecant and secant. Well, in this particular section, we're going to look at more involved graphs. These are the two main graphs that we're going to study in this section. And take note as to the letters and where they are, what signs they are, all that kind of stuff. These are the two main objects of our desire in this section. And we're going to break this down into several videos so that we don't run off and so that I don't run off and leave you, or so that this is a lot more understandable, hopefully. Okay, a lot more understandable for you, and well, if it's more understandable for you, it's going to be more understandable for me when I grade your papers. Okay, so first and foremost, let's look at y equals a sine x or a cosine x. So we're going to look at the letter in front of sine and cosine first. Well, here's basically what you can get, okay? How does the a affect the graph? Okay? How does the a affect the graph? Well, if a is, and these are all in your book on page 139, so I'm not going to write them up here, okay, to save space. If a is greater than 1, then the graph is going to be stretched vertically by a factor of a. So if a is greater than 1, it's going to be stretched vertically by a factor of a. If a is between 0 and 1, it's going to be shrunk vertically by a factor of a. If a is less than negative 1, then the graph's going to be reflected about the x-axis and stretched vertically by a factor of a, absolute value of a. Okay? And if it's between 0 and negative 1, it's going to be reflected in the x-axis and then shrunk vertically by a factor of the absolute value of a. Now, that's a lot of talk, I know. That's on page 139 in your book. But basically, this is what we call a. A is called the absolute value of a is called the amplitude of a graph. Okay? And basically what this is it represents the deviation from the maximum. Okay? So normally our amplitude of a normal sine or cosine graph is 1 or negative 1. That's the maximum value, 1 and negative 1. So this amplitude, this basically what A does is it affects how our normal sine graph looks like this. A is either going to make it, it can make it do this. It can shrink it. It can actually make it expand long ways. It can even flip our sine and cosine graph to where it looks like this. Okay, you know, A is going to cause a lot of variation in our graph. And it's basically going to give you the distance from the x-axis to the furthest point away from the x-axis. So for instance, in our normal graph, we had 1 and negative 1. And so our graph looked like this. Well, this distance 1 here and this distance negative 1, both of these are 1 unit away from the x-axis. So the amplitude of that particular graph would be 1. The amplitude of that particular graph would be 1. Now, what we can say is that the period doesn't change as well. The amplitude is not going to affect the period. So whether you have y equals sine x or y equals a sine x, the period is still going to be 2 pi. The period is still going to be 2 pi. Okay? So don't let that cause any discomfort. Okay? So let's see this. It's easier to see this in action. So, excuse me. So we have, let's look at these two graphs. Y equals 1/3 sine x and y equals -3 sine of x. And let's graph it from 0 to 2 pi. From 0 to 2 pi. So, we have 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so normal sine x is going to look like this. Normal sine x starts at 0, remember, and something like this. And this was 1, and this is -1. That's normal sine x. Well, look at 1/3 sine x. Okay, 1/3 sine x has an amplitude of the absolute value of 1/3, which is 1/3. So it has an amplitude of 1/3. So what does this do? Well, it's going to basically, since 1/3 is between 0 and 1, it's going to shrink our graph by 1/3. Okay, it's going to shrink our graph vertically by 1/3. So the highest point on sine x is 1. So what this tells me now is that the highest point on 1/3 sine x is going to be 1 times 1/3, which is 1/3. So the highest point here is going to be 1/3 of the value. The highest point here is going to be 1/3 of the value. What about the lowest point? The lowest point is at -1. So what's 1/3 of -1 is -1/3. So it's going to be right in here. Okay, so our graph is going to start the same. Still going to go through the same points, but notice the difference in it. Okay, notice the difference. It shrunk our amplitude of 1/3, shrunk our graph by a factor of 1/3. Okay, hopefully that makes sense. Well, let's look at -3 sine x. -3 sine x. Well, the absolute value of -3 is 3. So that means our graph is going to have an amplitude 1/3 times what our current graph does. So what that tells me automatically is that the highest point in our graph is going to be 3, and that the lowest point in our graph is going to be -3. And I know these graphs are not graphically correct, so to speak, but it's hard to get it where you can see it without spacing it out a little bit. So keep that in mind. There's a good picture of this in your book on page 140. All right, so now here's what you've got to pay attention to, though. Notice the negative here in front. Notice the negative. Well, what that's going to do is that means our graph is going to be rotated about the x-axis. So if this is the x-axis, that means it's going to be flipped. So where we think where we have a maximum here, this is a max, this is a min. Because it's flipped, our max turns into a min, and our min turns into a max. Okay? So it flipped our graph. Now, Everything else is going to stay virtually the same. We're still starting at 0. It just flipped our graph. So, and notice where I marked these. I didn't mark them down at 1 and -1. I marked them at -3 and 3 because our amplitude multiplied our current amplitude by 3. So 1 times 3 is 3, and -1 times 3 is -3, which is why we have those markings. So this graph is going to look something like this. Okay, this graph is going to look something like this. So not only did it multiply the current amplitude of 1, the amplitude of sine and cosine, remember, is 1. Not only did it multiply those max and min values by 1, of 1 by 3, not only did it multiply the max and min by 3, but it also flipped the graph because of that negative sign in front. So this is what fractional values and negative signs and larger numbers in front of the sign x are going to do. They're going to stretch your graph or shrink your graph depending on what those numbers are. Okay, and as I said, this same drawing I just drew, page 140 in your book, you'll notice my y-axis is a little unproportionate compared to theirs. Like I said, because I have to space things out so you can see it online. But theirs is fully accurate, and it's computer generated accurate, so you'll be able to see a better picture of it if you can't see it by what I've done here. Hopefully you can see it by what I've done here. Okay. Now it's going to be it's going to be very similar to cosine. Cosine is going to work in a similar fashion. It is going to the amplitude is going to still do the same thing for cosine that it did for sine. It's not going to change our period. Sine and cosine are going to function pretty much the same way. Okay, pretty much the same way. So keep that in mind as you are doing this. I'm not going to show you the cosine version of these, but it's going to work the same way that this one did. So this is graphing trig functions with the a in front, with the amplitude, with an amplitude other than 1. There's something in front of our normal graphs, but this particular graph has something other than 1, okay? So our next video will be on the b part of our function.